Well, this is a reenactment of the experiment that I did that night back in October 1969. It's a heated oven, and the segment of these polytetrafluoroethylene rods is being heated to about 300 degrees centigrade in this oven. And I was frustrated because everything I seemed to do worked worse than what we were already doing. And so I decided to give one of these rods a huge stretch, fast, a jerk. Voila!
With that pull, Bob Gore discovered that a remarkable polymer called polytetrafluoroethylene, PTFE, which is commonly known as Teflon, could be transformed into an entirely new physical state. His discovery, known as expanded PTFE or ePTFE, changed our world in new and surprising ways. This is the story of discovery and invention, and freedom, and a family. W.L. Gore Associates was started in the basement and garage of the home of founders Bill and Viv Gore in 1958. Today, the company employs over 10,000 people in 50 locations around the world and posts annual sales of over $3 billion. Gore is frequently ranked as one of the best places for people to work. It's also been called one of the world's most innovative companies. Today, W.L. Gore Associates makes more than 1,000 products, including everything from implantable medical devices to guitar strings. Perhaps, though, the company is best known for its high-performance fabrics.
Well, I'm Bob Gore of W.L. Gore Associates. My father came up with that name, and I'm better known as Bob Gore-Tex.
Bob Gore was born in Salt Lake City, Utah on April 15, 1937. His father, Bill, was a naturally curious, hands-on experimenter from as early on as Bob can remember. Armed with a bachelor's degree in chemical engineering and a master's degree in physical chemistry from the University of Utah, Bill Gore was a man who breathed science and invention. In fact, for a 1948 trip to Boy Scout camp, young Bob sported a homemade camping pack designed by his dad and sewn by his mother. That same summer, when Bob was 11, his dad devised a transparent plastic tent that the family used while camping in the mountains of Utah.
He was a person of great enthusiasm. He always was thinking in an optimistic and positive way. He took his family backpacking, and we always took new trails and had new adventures. He loved the outdoors. I certainly remember the first time he took me on a hike up in the mountains. I was 5 years old at the time, so I was barely able to keep up, and he would tell me, well, it's just over the hill, it's just around the corner, it's just Bob, just keep at it, you know. And so that was the way he was, and pretty much through my entire life.
Just around the corner is a philosophy that Bill Gore held close to his heart. He spent much of his life searching for that next thing that would bring him the freedom to discover that he craved. Bill Gore entered the DuPont workforce during World War II at its Remington Arms plant in Ilion, New York. From there, Bill and his family moved to other DuPont facilities on the East Coast before ultimately transferring to the newly built DuPont Experimental Station in Wilmington, Delaware. In the spring of 1950, Bill and Viv Gore purchased 15 acres of farmland on Paper Mill Road near Newark, Delaware. Although he consulted with an architect, Bill Gore decided that he would design his own house, act as his own general contractor, and be a hands-on worker during the construction. Bob and his siblings assisted where they could. In fact, Bob dug ditches for the electric cables that would run to the house. After construction was underway, Bill, Vive, and their 5 children lived in the basement for a full year while the rest of the house was completed.
It's kind of interesting because I read a personality profile on my father, who was an entrepreneur. And one of the things that happens is the family members often get drawn into adventures that are sometimes dangerous. But the optimism of the entrepreneur is such that it will always work out, we'll always find a way. And so it was in business too.
Bill Gore worked at DuPont as a research supervisor for 16 years. He helped to advance the company's research into polymers, resins, and plastics. In 1952, he authored a book titled Statistical Methods for Chemical Experimentation. While Bill Gore's career at DuPont was flourishing, his entrepreneurial spirit was itching. He had dreams of making it on his own, building a company where innovation was the main attraction.
The company that he envisioned was one where people had lots of personal freedom, freedom to grow in competence and grow in their profession. His vision was definitely a non-bureaucratic, free, entrepreneurial company.
Bill Gore was intent on forming his own company. He had the will, the brains, and the strategy. All he needed was the one idea that would allow him to branch out on his own. He was always looking for the practical potential in new materials and was convinced that there was a use for polytetrafluoroethylene, PTFE, a fluoropolymer discovered in 1938 by Roy Plunkett, a chemist with DuPont. In fact, DuPont's Teflon is one of the best-known brand names of PTFE. Bill was excited about this new material that possessed a number of remarkable qualities. For one, PTFE is made of a carbon backbone chain that's protected by fluorine atoms, which attach to it in one of the strongest bonds in chemistry. It is water-resistant, non-flammable, and has excellent resistance to sunlight and weather. It possesses excellent thermal and chemical stability and has unsurpassed electrical properties. It has a very low coefficient of friction. And, as it turns out, PTFE is biocompatible. It is capable of coexisting with living tissues or organisms without causing harm.
This material had all sorts of wonderful properties, but it was very hard to make anything out of it. So it wouldn't melt and be thermoplastic enough to be formed by normal techniques. And so he saw how if this could be made into the right kinds of shapes, right kind of forms, there'd be great opportunity.
Bill made a lab in his basement. At great cost, he commissioned the creation of a machine which, he thought, would allow him and Vive to create wide sheets of PTFE from powder.
The first thing he tried to do was to make a very wide sheet of Teflon. And I can picture my mother down there under the rolls trying to pull bits of sheet out, and him feeding the powder in the top of the rolls and hope that he formed a coherent sheet.
Bill and Vive spent nights and weekends in their basement/laboratory, trying to make the idea work, but it proved too difficult. They shifted their plan and pursued another idea that they believed had commercial potential. Bill would try to develop a process for insulating a series of parallel electrical wires using PTFE.
One night when I was going to the university and I came home, and it was probably 5 o'clock at night, and it was getting dark, and he said, "Come on, Bob, come on down and let me show you what I'm doing." I could see that him feeding powder into these rolls was a very difficult thing to do, because while some of it would pinch and form a nice sheet, some of it would have little cracks in it. And I could visualize that these particles wouldn't necessarily, even where they looked like they formed a nice coherent piece, might have little cracks. I said, "Well, why don't you take this thread sealant that you've got here and feed it in between the rolls? It's already formed into a coherent sheet." And so he said, "Oh, Bob, that won't work. It's already, these particles have been sheared. They no longer will adhere."
That night, Bob, who was a sophomore at the University of Delaware at the time, completed his homework and went to bed.
About 4 a.m. the next morning, my dad's shaking me. He says, "Bob, wake up, wake up." I went down, and he had a little tiny piece of Teflon, and he pulled at it and showed that the two pieces had adhered together. So he went to work, and when he came home that night, we set it up with the tape going into the rolls. And when it fed into the rolls, it looked like the tape on each side adhered around the wires, and it seemed to test out. So he was very excited.
Bob's idea was the fuel that Bill Gore needed to move quickly on his dreams of his own company. Although he needed to do further work on the invention, Bill Gore was ready to follow his entrepreneurial instincts and set out on his own. Bill and Vive Gore began W.L. Gore Associates on January 1st, 1958, on their 23rd wedding anniversary. Bob Gore, on the other hand, still had his studies at the University of Delaware to complete. He spent his summers working at a local chemical company, which was just starting rocket research, their answer to the Soviet Union's launching of Sputnik, the world's first satellite.
They were willing to pay me more than my father was, by quite a bit, and he didn't seem to need me right then. He was enthused. He brought in some of his DuPont people to help him, and brought in other members of the family. My grandfather came from out west to work in the basement.
As Bill Gore and his team labored to perfect a product to sell, the Gore basement became a hive of activity. From the start, the emphasis was on building their own equipment rather than purchasing it. When equipment or parts were needed, the kitchen was one of the first places searched. In fact, Vive's electric frying pan was converted into an early dip tank for PTFE processing. Bob Gore graduated with his bachelor's degree in chemical engineering at the University of Delaware in 1959. He then moved to pursue his graduate studies at the University of Minnesota, earning a master's and then a PhD in chemical engineering in 1963. While Bob was finishing his studies in Minnesota, a lot was happening in Delaware. For starters, the company changed its place of business from the Gore's basement to a new facility nearby about a half a mile across the valley. They promoted their line of wiring cable products that maximized the unique qualities of PTFE. The first big breakthrough for W.L. Gore Associates came about because the city of Denver was installing a new citywide water system. They needed control cables that could be buried underground. Gore's Teflon multi-conductor signal cables were a perfect fit for the job. They were rot-proof and would not decay or deteriorate in the soil or the moisture. The city of Denver ordered miles of this cable to use underground. And to produce the order, the company hired 50 new people. W.L. Gore Associates was on its way. They were able to keep production going as they moved manufacturing from the basement to the new plant without a pause. No one was more pleased than Bill Gore.
He was building a company where he could enjoy himself. He was making progress on new things. He could teach people in the plant. He could do the things he wanted, and pretty much saw that everybody else could do the things they wanted in working at Gore. And certainly I chose, finally, to go there because I could see that I would have more freedom to do the things I wanted at Gore than if I joined some other companies.
Bob joined W.L. Gore Associates full-time in 1963, working side by side with his dynamic father and his mother, Vive.
She was a very supportive person, both to my father and to all of us 5 children. I believe that she was kind of the heart of the enterprise. She tended to befriend people who were very spunky, but maybe on hard times. So many of the first people we hired were coming up from West Virginia, which was a depressed area. And many of these people were living in their car. She was the one who brought them in, could see that they had a lot of get up and go and spunk, as she would call it.
W.L. Gore Associates was based on the idea of solving customer wiring problems by providing customized wire. And as the computer age approached, the company was poised to make a significant impact on this emerging technology.
IBM decided to mass produce a computer system, digital computer system, and that was the IBM 360. Today, if you look in a computer, there's almost no wire and cable, whereas those first computers were filled with cable. It was almost impossible to have a box big enough to contain all the cables that were in it. And Gore, because of all the good qualities of PTFE, polytetrafluoroethylene, had gotten the contract to supply the system.
W.L. Gore Associates became key suppliers of their PTFE coated wire to IBM and other computer makers, an extremely satisfying and profitable venture for the company. Other industries found that Gore's wiring cable suited their needs, including the U.S. Defense Department and the National Aeronautics and Space Administration. The earliest Gore space applications were on some of the Surveyor satellites, the first U.S. spacecraft to land safely on the Moon. The main objectives of the surveyors were to obtain close-up images of the lunar surface and to determine if the terrain was safe for manned landings. And on July 21, 1969, the company played a key part in history when NASA's Apollo 11 landed on the Moon. Astronauts Edwin Buzz Aldrin Jr. and Neil Armstrong installed seismographic equipment connected to the lunar lander with a small, lightweight cable manufactured by Gore. The lunar landing was a source of great pride for W.L. Gore Associates, but the company could not rest on their laurels. They knew they had not yet exhausted the number of commercial applications of PTFE.
Towards the end of the 60s, now I'm looking for something new to do. Here I am, supposedly the R&D arm, and, okay, well, what's next? What's around the corner?
As it turns out, Bob was presented with a challenge. One of his colleagues had promised a client a totally new version of the company's reliable electrical tape. Bob was charged with the task of converting the tape into a very inexpensive new form of plumber's tape. This would create a new market for the Gore Company and save significant production costs in the new process. The idea was a good one. By introducing air into the PTFE structure, you could stretch the product, in effect replacing the expensive PTFE resin with air.
Well, it ends up that you can stretch plumber's tape 50% when you do little bits of it. But when it all has to be stretched 50%, it ends up that there's defects and it breaks and you can't really manufacture it.
So he sold something you hadn't invented yet?
You're right. But that's a good incentive. Now we were supposed to make this product, but we couldn't make it on a reliable basis. So we could make 10 feet or 20 feet of it, but we couldn't make continuous lengths.
As head of Gore's R&D department, Bob felt the pressure of fulfilling this client's order. As a chemical engineer, Bob had some unanswered questions about PTFE and wanted to conduct fundamental experiments to find out what might allow PTFE to be stretched. And although he had all the company's production equipment at his disposal, Bob followed his instincts and retreated to the lab to begin his research with a rod of PTFE rather than tape.
I realized that all the equipment we had was way too complicated for me to know what was really happening inside it. So I set out to do my own hand stretching. And when I did it slowly, I would do it this way very carefully. And this rod that was stretched between my hands would just fall apart and break in the middle. So at that point, and I was alone after work one night in the lab, and I was frustrated because everything I seemed to do worked worse than what we were already doing. And so I decided to give one of these rods a huge stretch, fast, a jerk. And I really said to myself, if you won't pull slowly, I'm going to give you a jerk. And I gave it a huge jerk, and it stretched 1,000%. I was stunned. I didn't talk to anybody. I went home that night, and I came back early the next morning. And so, sort of one by one, first I called our chief engineer in and showed him. And pretty soon everybody in the plant was doing this experiment. And when I showed my dad this experiment, he immediately could envision all of the wonderful things that could be made out of this material.
Bob's discovery of this new form of a high-strength porous material polymer, expanded polytetrafluoroethylene, or ePTFE, was a transformative moment for the company. It set the stage for explosive growth. Soon after, Gore was producing a wide range of forms of ePTFE, including fibers, tubes, membranes, and custom shapes. This resulted in numerous products that included new electrical cables, industrial filters, medical implants, textiles woven from ePTFE fiber for space exploration, and laminated fabrics for outdoor activities, emergency response, and defense.
PTFE has a low surface tension, and so air could go through it, but not the water droplets. So we envisioned the waterproof, breathable fabric for backpacking. And of course, being backpackers, here was a product that I could actually use, could actually test myself. And so I've spent a lot of my time on developing our fabrics business.
In 1976, Bob was named president and CEO of Gore Associates. From the start, Bill and Vive Gore had strong ideas about what kind of company they wanted to create. Their goal was to construct an open, energized atmosphere where information and ideas flowed. It was a friendly place. Company parties included everyone. They had a fundamental desire for employees to have ownership in the enterprise, thus becoming true associates of Gore. Bill's passion for creating and sustaining a unique Gore company culture is fully realized in the Gore Associates of today, a privately held, team-based chemical company that forgoes traditional hierarchies. At Gore, employees don't have conventional job titles. They are associates who manage themselves, as Bill Gore put it, and benefit from a rich stock ownership plan. Bill Gore died in 1986, and Vive Gore died in 2005. Together, they had crafted a strong company, and their voices are still a guiding force at Gore Associates.
One of the quotes that I keep in my mind is, jump in and see if you can swim. And he would say that fairly often. You can study something, and you will never foresee all of the issues or opportunities or problems that might arise. But the minute you jump in, your energy level goes way up as you try to keep from sinking. And this was a thing that he was very good at.
Today, Gore Associates is a uniquely inventive, technology-driven enterprise still focused on discovery and product innovation. Virtually all of Gore's thousands of products are based on just one material, PTFE. From applications that enable space and commercial aircraft to durable, protective fabrics for the U.S. military, to more than 35 million innovative Gore medical devices that have been implanted. That one material, combined with Gore's technical know-how, has contributed to a stunning number of processes and creative, reliable technologies that continue to solve problems and change lives around the world.
It was always over the hill and around the bend, and many of the trails we took weren't trails at all, but we would get ourselves in various and sundry fixes. They called him the supreme optimist. He called me the supreme skeptic. And so we worked together very well.